In this video, we'll be continuing to multiply polynomials. And so before we get into it, we have to review what exponents are. And so the definition of an exponent, it represents repeated multiplication. So for example, if we have this 3 as the exponent here, that means that we are going to take this 4 and multiply it by itself 3 times, which gives us 64. Even if we have a negative number to the exponent, that means we take the negative 2 and multiply it by itself 2 times. That's going to equal 4. And the same thing applies to variables. X to the 4th power, that means we take the x and multiply it by itself 4 times. So whatever number it is in the exponent, that's how many times it multiplies it by itself. But of course, we expanded to x to the 4th, and then we can put it back to x to the 4th if we want. And so we started a bit of distribution. I remember distribution means multiplication, and so we're going to take this x and multiply each of these terms. We can change this subtract 5 to adding a negative 5. And so to multiply, we're going to multiply x times x. That's going to give us x times x. Plus, and then we multiply x times negative 5, so that's going to be negative 5 multiply x. And so x times x is x squared plus negative 5x. That is the active distribution and what we're doing a little more today. So this box method we're going to go over on the second set of notes, so we will come back to this portion. And so what we want to be able to multiply is not only one number to distribute, but now you should notice that we're going to be multiplying x plus 1 multiply x plus 2. And so before we even get into the work on how to do this, on what the distribution process actually is, we're going to take a visual approach and we're going to look at this visually. So we're not even going to learn how to show the work to multiply this yet, okay? Because what we're going to end up doing on the next set of notes is we're going to take this x, we're going to multiply it to this x, we're going to take this x, multiply it to this 2, we're going to take this one, multiply it here, we're going to take this one, multiply it here. But like I said before that, we're going to go over some visuals. And so we're going to use these pieces here. So this square, one side is x, the other side is x also. So that means this piece, x times x, is going to be x squared. So this is the x squared piece. This little rectangle here, this side is x, and this top portion is going to be the number 1. So x times 1 is x, so this is the x piece. And then for this small square, this is going to be 1 by 1. 1 times 1 is 1. So this is the 1 piece. And so to set this up visually, we want one of the sides to be x plus 1 and the other side to be x plus 2. And so what do I mean by that? So the x plus 1, we're going to take this right here because we remember that this side is x, just like we have up here. And then the plus 1 is we're going to get another piece here. And so remember this piece, as we can see up here, this side up here is 1. So that means the top part of this rectangle is currently x plus 1. And then we want the other side to be x plus 2. So we're going to take 2 more pieces, 2 more rectangles, because once again, remember this side of that rectangle is 1 and 1. So this whole thing is x plus 2. And so we want to fill in the number of squares that will make a complete rectangle. And so that's going to be 2 more squares like so. And so how does that actually give us our answer? Well, we have to count up all the pieces. This was the x squared. So we have 1x squared. Here we have this piece right here is an x. This is also an x. This is also an x. We have plus 1, 2, 3 x's. And then remember the orange piece is a regular 1, so that's plus 2. So this is our polynomial, and we can write it without the 1 if we would like. But it is the same thing both ways. And we'll be doing this method for the first part of class and showing the work for the second part of class. Now let's look at x plus 2 times x plus 3 visually. We have the same pieces. This is x, that makes this whole thing x squared. This side is x, this side is 1. 1 times x is x. This side is 1, this side is 1. 1 times 1 is 1. So we want x plus 2. So we take one of these pieces, because this is x, and then we want plus 2. So we're going to take 2 of these rectangles. Plus 1, plus 1. So that's x plus 2 for the top part. And then we want x plus 3 for the other side. 1, 2, 3. X plus 1, 2, 3. And so we want to fill in the rest of these until we get a full rectangle, and looks like that's going to be exactly 6 pieces. So once again, we can get our polynomial from here. We have x squared, x, 1, 1, 1, 1, 1, 1. So that gives us x squared plus 5x plus 6. Last one. Now we want x minus 2 times x plus 4. If we want, we can change this to x plus negative 2. And so we'll take this piece for x. We want negative 2 this time. So the only difference is that when we label these, this will be x, but this will be negative 1, negative 1. Okay, so that means this piece right here, instead, it's going to be negative x and negative x. And so now we want x plus 4 on the other side. 1, 2, 3, 4. And since these ones are positive 4, x plus 1, 2, 3, 4, these will be positive x. And so we fill in the rest using these squares, and that's going to be 8 squares total. Okay, and so we think, what are these squares going to be? Well, if we look at this side of the square, that's going to be negative 1, and this is positive 1. So negative 1 times positive 1 is negative 1. So all of these are going to be negative 1s. So that means our polynomial is going to be, we have x squared plus, we have 2 negative x's, so that's negative 2x. We have 4 of these x's, 4x. Then we have plus negative 8. So we combine like terms, which are these two terms in the middle, and that gives us our final answer of x squared plus 2x plus negative 8. Thank you for listening.